All right, so we're going to wind up doing these problems from the 3-6 outline. Okay, so you may want to take notes on the outline as we do these. All right, so the first example is starts out with arcsine of t squared. So the formula for that, for arcsine, the derivative of arcsine, was going to be, remember it was u prime over square root of 1 minus u squared. Okay, that was the formula. Just back from here is where I'm getting it. Okay, just right here. All right, so if we're trying to do the derivative of arcsine of t squared, then u equals t squared, right? Maybe go ahead and do u prime over here while you're at it. It would be 2t, wouldn't it? So then you can plug into the formula, and you're going to wind up having 2t over the square root of 1 minus t squared squared. Okay. Now you can do just a little bit of simplifying on this. The t squared squared would be t to the fourth. And then that's what you would type in for your answer. Okay. All right, let's go to the other one, the arctan. Okay. So you go back up, you look at your formula for arctan. For arctan, it's going to be u prime over 1 plus, no square root on it, 1 plus u squared. Okay. All right, so start memorizing those and being able to get them and effectively use them. All right, so when you do f prime, oops, this time it's an x, of x, you need to look at how on this one, u is the square root of x, okay, and that's x to the 1/2 power. So u prime would be 1/2 x to the negative 1/2. Okay, so I have 1/2 x to the negative 1/2 over 1 plus the square root of x squared. Okay. All right, so that winds up being 1 over 2. This 2 would go down here, be 1/2, times the square root of x. That's the x to the negative 1/2 moving to the denominator. And then all of that times 1 plus, and square root of x squared would have been 1 plus x. Okay. All right. And so let me just rewrite that without all the circles on it. So 2 square root of x times 1 plus x would be okay to just leave it in that nice factored form. You could distribute the square root of x, but it doesn't really make it look any better. Okay. All right, now I'm doing one. This one is cotangent. So if I know the derivative for arctan, then arccotan is going to be that same thing, but just with a minus on it. Okay, so when we go to do this one, we'd want to identify the u. Think of it as 2x, this time in parentheses to the 1/2 power. We need to do u prime, which would be bringing the 1/2 down, multiplying by 2x to the negative 1/2 then, times the derivative of the inside function. And then this 2 and this 1/2 would equal 1. So we'd really have 2x, make sure you're thinking of it in parentheses at this point, to the negative 1/2 power. So the formula has us do u prime on top. So that's the 2x to the negative 1/2 power. Then we do the 1 plus the square root of 2x in parentheses squared, because that's the u and it's supposed to get squared. And then this was an arc cotangent, so the formula has a negative on it. Okay. So on this one, let's see what I get here. So I have a negative. All right. All of this moves to the denominator, and all of it is under the radical. So I have square root of 2x under the radical, all from this thing on top, okay? And then that would be multiplied by 1 plus, and then the square root of 2x times itself would be 2x. And then what you need left on top is the 1. And you'd be done. Okay, so these problems really are a matter of you taking the time to know the formula. But when you get to one like 26, this one has a product rule, and one of the functions has arctan in it. So you have to recognize that. So when you're thinking arctan, you know that the u would be 5x, so the u prime would be just 5. Okay, but this is a product rule problem. So when I go to do the derivative of the h function, I'm going to do the derivative of the first, which would be 2x, times the second function as is, no changes. Okay. All right, then I need to add to that the first function as is times the derivative of the arctan of 5x. So we did that earlier. So let me move this down a little so you can see the formula. That was the formula for the derivative of arctangent. So it's u prime, which is 5, over 1 plus the u, which is 5x, in parentheses, squared. Okay. All right, so let's see how this one looks. So we have 2x arctan 5x plus, I'd probably move that x squared up with the 5, make that 5x squared. All of that over the 1 plus 5x times itself would be 25x squared. And look, you can't factor a 5x out of the denominator, so don't try to cancel a 5x or anything of that type, or the x squareds, because of this plus sign right here. You're not able to factor 5x or 5x out of there, right? And then that's typically how you'll see the final answer. Sometimes they'll put things that are two terms, they'll combine those into one by getting common denominators. So like over this one now is really over 1. So if they did it so that it had a common denominator, it really would look very awful, because you would take this top and bottom, you would have to multiply by 1 plus 25x squared. So it doesn't really make it look more simple. Then you could add the 5x squared, and then all of this would be over 1 plus 25x squared. So you don't typically go there on one like this, because it really doesn't clean up very well, and it doesn't turn out to look nice. And you got to really watch it, because that 5x is connected to arctan right there. So don't think you can factor out 5x. Now you could factor out an x. Okay, you could take out an x from this first term and from here, but you can't take out a number or anything else. Okay, so we typically don't go there. Our final answer, we would have left it right here. Okay. But it would have been okay if you did. All right, so that was a one involving the derivative of arctangent, but we also had to remember how to use the product rule. All right, let's look at this one. All right, let me see if I can get more paper before I need it. Yeah. Okay, so this one was two terms to start with. See that minus sign right there? So you can do the derivatives of things term by term. So the derivative of natural log is 1 over your input, okay, times the derivative of the inside function, which is 2t. Okay. All right, and I'm not using a product rule. I'm just doing, because these are two separate functions separated by pluses or minuses. We have two terms. So all we have to do is do the derivative of each term. So we do that. Then here, we bring the 1/2 down. That was a numerical coefficient. That's just a constant. And then we're going to focus on doing this piece right here. So this is the formula that says the derivative would be u prime over 1 plus u squared. And here the u would equal the t over 2. That's 1/2 t. Okay? All right, so let's go ahead and do it. So it'd be minus 1/2, and then I'm going to start doing the derivative of the arctangent of t over 2. So the derivative of the 1/2 t would be 1/2, and then I'd need to do that over 1 plus t over 2 squared. Okay. All right, so now I'm going to see what all that turns out to be. So 2t over t squared plus 4. Then here I have minus 1/2 times this. That 1/2 can go with that 1/2 and become 1/4. Okay, so it's really a 1/4 over a 1 plus t squared over 4, like that. And that 4 is only under the t squared, right? So what I'm going to do is I'm going to work on this second term to start with and clean it up a little bit by multiplying by 4 on top and bottom. So I'm going to multiply by 4 here. And when I multiply by 4 here, it has 2 terms, so don't forget to distribute it to both terms. So we'll have 2t over t squared plus 4 minus 1 over 4 plus t squared. And these are both positive. The 4 and the t squared are both positive. So really I have the same denominator. So this is just 2t minus 1 over 4 plus t squared when I'm finished. Okay. All right, so do you see the difference in why this wasn't really any kind of a complicated product rule? We just had a minus between these two things. So it's just a matter of doing the derivative of the first term, which was the natural log part, and then the derivative of the second term, which was arctangent. And ln of t squared plus 4 is not ln times. There's not multiplication between the ln symbol and the t squared plus 4. That's just function notation. So the derivative of a logarithm function, natural log, is going to be 1 over the input, but then you have to take the derivative of the inside as well. All right, let's do one more. This one has a minus. So you get your bearings first. We have 2 terms. This second term right here involves natural log, and there's just a numerical coefficient of 1/4 without having a variable along with it. So the derivative of that second term is just a regular type. It's not one where I have to use a product rule, okay? But the first term does have times between the x and the arctan of 2x. So we'll have to be careful about that, okay? All right, so we kind of thought through our plan. Going to use the product rule on this first part. So I'm getting ready, and this is where I did y prime here. I'm getting started doing y prime here. So the derivative of the first function would be 1. The x would be 1 times arctan as is. Okay. I'm going to move this problem because I want to be able to go to the right a little more. So let me grab that, see if I can grab that. Oops, I meant to be in my circle it mode. Let me grab that and see if I can move it. Sorry, it's just as easy. Okay, so I just want more space. I'm going to write the problem over again, but this is that number 38 on the bottom right. Okay. All right, so here on 38, okay, the problem was y equals x, and that was being multiplied by arctan of 2x. So you see how you have that x in that first function, so that makes it a product rule problem. But the second term doesn't have an x with the 1/4, So it's not a product rule situation. We just need to remember how to do natural log. Okay. All right, so I'm getting ready to do this one. I'm going to do this one in red. I'm going to move over a little bit because it's going to be long. Derivative of the first function is 1, and then you multiply by the second function as is. Okay, then I'm going to add to that the first function as is, and here's where I'm now going to do the derivative of arctan. Okay, so remember the derivative of arctan is u prime over 1 plus u squared. Okay, the u on this one is 2x, u prime would be just 2. So you're going to multiply by the derivative of arctan now. So that would be 2 over 1 plus, make sure you're thinking about that 2x being in parentheses raised to the second power, because that 2 has to apply to both the x and the 2. Whatever u is getting squared. Okay, so I finished the derivative of this term, okay? And I had to use the product rule to do it. Now I'm going to move to this term, okay? And do the derivative of it. So it's going to be minus 1/4, just bring the constant down. Then the derivative of natural log is u prime over u. It's like you do 1 over your input times the derivative of the inside function. So by now we've done it a lot. You might like just thinking about it like this. Okay. So the u on this one is 1 plus 4x squared. So the u prime would be 8x. Okay. So we would get 8x over 1 plus 4x squared. I usually do 1 over 1 plus 4x squared, and then I multiply by 8x because I'm not really just memorizing that formula. I'm thinking about it like like a composed function where you have to do the derivative of the inside after the fact. But we've done that a lot, and we're basically just using the formula for arctan, so we might as well just use that idea for natural log. Go ahead and put the 8x right there on top. All right, then you work to clean it up as much as you can. So I get here arctan of 2x. Make sure you're thinking about that being grouped. Arctan of 2x is all part of the arctan, the input to arctan. Here, I would have 2x on top and then 1 plus 4x squared, because that's 2x times itself. 2x in parentheses squared means 2x times 2x. Then here I have minus 4 goes into 8 twice. So I have minus 2x over 1 plus 4x squared. So these cancel out, and we wind up with this one turning out to be just arctan of 2x. Okay. All right, so don't want you to make too much of those. The hardest part on the derivatives of these inverse trigonometric functions is you learning those rules, memorizing them, getting them straight, make sure you have them in the right order. When you get to the secant one, make sure that you have the square, make sure on secant when you're trying to memorize it, make sure that you're thinking about under the square root. It's kind of like on arc sine, how it had the square root, but it's got the u squared minus 1 on it. Okay. That's the derivative for arcsecant. Anyway, so work on memorizing those, and then it's just a matter of being able to use that formula.